Oh, hello. Good morning, everybody. I am Jonathan Sander, and you can find me on the internet at SanderIM, and I am going to apologize to the board members of ID Pro, because even though I'm a founding member, I did not put an ID Pro logo anywhere in my slides. So I'm a bad ID Pro member. But I'm saying you should all join ID Pro, and if you don't know what I'm talking about, go all the way to the back of the show floor and find the ID Pro desk there and find out all the advantages of being an ID Pro member. So here's what we're going to do. We're going to talk about machine learning in general, and we're going to talk about it using examples from security and identity. Because here's what I really wanted to do today. I wanted to communicate two things to you. One is a story. The story is how STEALTHbits completely screwed up trying to use machine learning in its product line, and why that happened, and the misconceptions we had that caused those mistakes. But the problem is I can't really tell you that story until I establish a lot of other things, right? So first of all, I'm going to need to establish some common lexicon for us to talk about that. We're going to talk about how we first went out and looked at SIM and thought SIM was the perfect problem to apply machine learning to, and how utterly wrong we were about that. And last but not least, we'll get into a little bit of how we might be able to do this a little bit better, and we'll also talk about why you might want to go through all the trouble of using machine learning. Okay, so at a conference like this is the exact kind of slide you should dread, right? It's definitely got the fingerprints of my marketing department on it, and this is how most people try to communicate things about machine learning. They try to tell you what algorithms are first, because algorithms sound cool. And usually then they give a little bit of attention to models, features, and data. Okay? I am not going to do that. I am instead going to try to communicate this to you with a video of toy cars. Okay, so this is what we're going to do. Now, first of all, to get this video to work, I'm going to flip over to the actual video file. And here's what's going to happen. We're all going to watch this together, and I'm going to talk you through it. All right? So what we're observing here is something, by the way, you can find on the internet. All you have to do is Google machine learning cars. I guarantee this will be the first hit. And this is just a visualization from a researcher who was basically trying to take his data and get funding for it. Right? So we're not watching learning taking place. We're watching a video that essentially visualizes what happened during the training of a system. By the way, if you're not emotionally invested in these cars getting through this maze at this point, you have no soul, right? But I promise you, we're going to get there, right? Now here's the thing. Up in the upper left-hand corner, that's the algorithm. That's the part that most people like to talk about. It's the cool mathematics, and by the way, I love cool mathematics, but it's not the important piece. If you look at these cars, at the front of each one of them, you'll see 5 little green dots. From each of those green dots, there is essentially an invisible, unfortunately, whisker, let's call it, that goes from the car to the edge of the maze. Okay? That, my friends, is a feature. Okay? That's a feature. That is what is actually being measured here. It's not the only thing that's being measured. They're also measuring momentum, velocity, angular play as the car turns and such. You thought it was going to make it there, didn't you? But these are the features that are actually being measured. This is what makes the difference between the car making it through the maze or you getting the result you want from your machine learning system. Okay? That's what's really important. The maze itself represents a model. Okay? These are the constraints that I need to put on my data in order to have that data be meaningful in the long run. Right? Basically, if I just throw a whole bunch of data into mathematics, as Randall put in the cartoon at the front, I'll get some results, but not meaningful ones. I need a model that puts constraints on this that actually allows me to understand what the features have done, okay? And of course, the data itself is extremely important. Nothing happens here unless the measurements come out right? You're never gonna make it through the maze unless you have things going. Now, you notice, by the way, there's always an arrogant car who thinks it can go too fast, and it never makes it through. And by the way, it's not the fastest one who gets to go through. it's the one who does it right, okay? So there we go. Now, by the way, this goes on for about 46 more generations. I'm not gonna put you through all the generations of this, but I will skip ahead and show you that essentially, what happens here is that they learn in what's called supervised manner in this case, which means they're getting feedback through that algorithm to adjust the values of those features, and that's one way you can do machine learning, and as you can see, a whole bunch of the cars end up getting out in the end because they're improving their relationship between the data and the model, and therefore getting better results, or the features in the model, and therefore getting better results out of the data, okay? Hopefully, what this has done is given you a better understanding of, let's see, where are my slides? There are my slides, of features, a model, and the data's relationship to it. Because I'll tell you this right now, if you want to apply machine learning to security, to identity, or to anything at all, that's going to be a lot more important than understanding the difference between cluster models and neural networks and all that kind of jazz, right? You can hire smart people to manipulate that stuff. But what we're going to talk about is it's really hard to get those people to be effective if you don't understand this part. If you don't understand what features are, if you don't understand their data and how you need to model that, right? So with that in mind, essentially, an easy shortcut to understanding when you apply machine learning to a problem is that when you know the data, in other words, you have a lot of data, and you know the outcome you want, which is counterintuitive, by the way, right? But this is the truth. When you know the outcome you want, that's when machine learning is good. Because what you're training the machine to do is the shit work, right? That's the whole idea. You already know what you need. You already have this big pile of data. You just don't want to sit there with an abacus and figure it out, right? That's the whole point of the machine learning system, is to take that work away from you, right? So that's when you apply it. Now, maybe you're asking yourself, well, why would I use machine learning at all, right? What is the reason for doing that? And of course, one of the biggest reasons for using machine learning is because you're trying to impress your boss, your banker, your VC, or someone else. Because machine learning just sounds cool, right? You put it on a slide, and it has a big impact on the room, right? Everyone thinks, oh, this is cool. But that's not really the real reason, right? What machine learning does, in essence, is it makes prediction cheap, okay? And when I say cheap, I mean that in the economic sense, right? So computing made arithmetic cheap. And all of a sudden, a whole bunch of problems that used to be done in different ways became arithmetic problems because there was a cheap resource available, right? That's not exclusive to computing, by the way. Oil rigs were built before there was really a use for oil. There were a lot of other things that were using energy in the same way, but they weren't oil problems. They weren't gasoline problems. They weren't problems like that. Problems were converted, translated into that because a cheap resource. And it's hard to think of oil as a cheap resource, but if you go back and look at whale oil and the economics behind that, you will discover oil is a hell of a lot cheaper than what they were doing before. And that cheap resource transformed a whole bunch of technology and industry, right? And the mathematics thing came after that when computing made arithmetic cheap. And, think about this. How many forms of communication were digital before the internet was there, right? How were we communicating before the internet? I can't see the audience that well. I don't know how many old bastards there are out there like me who understand what that means. But the idea is that the prediction that a machine learning system can do is going to transform a lot of problems into prediction problems, right? I'll give you two examples. Right now you have self-driving cars, right? They tried to do self-driving cars in a rule-based approach, and they failed miserably, right? These things never even made it out of the lab, basically. Then they tried to apply machine learning to it, and funny enough, they got all the questions wrong because they were going for the wrong features. That's a whole other presentation. But now if you go and read the state of the art for self-driving cars, the real thing they're trying to do with machine learning in that area is say, what would a human do? Can I build a system that would accurately predict what humans do? Now, by the way, everyone who's ever driven a car is thinking, humans can't drive for crap. But we're better than the machines at it for the moment, right? We're better at the machines. And if we can build a system that can accurately predict what a human can do, right, that would make the machines a lot better. Tomorrow, if you're smart, you will go see Eve Maller present. She's going to talk about how machine learning is being applied to things like consent frameworks. We've been talking a little bit, if you've been watching some of the presentations on privacy and consent throughout the conference. How do we hand over data? Under what circumstances? How do we negotiate a contract? And if you keep up with the literature, you'll hear things like smart agents that get involved. Now, that character and myself and others were arguing about this on Twitter, but we're clearly hippos, and Eve's got real data, and she's trying to apply machine learning to it. And the idea would be, can the smart agent predict what you would do with your data, right? Can we build a machine that would predict what you would do based on the context and the circumstance, right? The data and the model, okay? So, when we, and I say this as we, not just STEALTHbits, but a lot of others, got machine learning into our grubby hands as a security tool, a lot of us went right to SIM, right? Why? Well, because SIM has tons and tons of data, right? It seemed like that would make a really good candidate for using machine learning because it had so much data. And the idea was that we wanted to model what users were going to do, and hey, it's a prediction problem. Can I predict if this thing is normal or abnormal? Is it an outlier or is it not an outlier? Can I predict what they're going to do based on what I see them doing now, based on what I've seen happen before? It has all the qualities you would think that a machine learning problem would have. Except the minute we did this, we all learned a painful lesson in the phrases false positive and false negative. I love this image, by the way. I absolutely adore this image. Obviously, that would be a false positive, unless you really wanted a goldfish. Then I guess it could be. So here's the thing. This is my really sophisticated diagram of SIM data, okay? But let's think back to the cars. Let's think about the elegance of the designer of that visualization and the model that they created, and the features that they were measuring to get results. Now, you all know this data well enough, probably, to start thinking about, at that top level, after I filtered up all the data from the SIM, what features would I measure? What does that data have in common? What could I use to be powerful and predictable? Before you get too many steps ahead of yourself, how much of that data is in formats that's even compatible to match up and talk about, right? Forget about the fact that I've got different operating systems down there, just the idea that different systems log differently on the same operating system, right? And now you're filtering all this up to your SIM, and you're trying to build a nice little car path with measurable features. How do you do that? By the way, if you know the answer to that question, see me after. I have money for you. But the point is that it's really, really difficult. And I bet most of the people who attend this conference are extremely intelligent. You're working out for yourself just how difficult that is. You're trying to think about this. I'm putting you in the position of somebody who's really important right now, right? And I'll talk about that person in a second. But here's the thing that a lot of companies tried to do. They tried to put systems like this in place, and then they tried to compensate for the fact that they weren't getting the results they wanted. They used things like peer group analysis. They redefined success to mean I'm just looking for outlier data, or they went hybrid. Now, by the way, even though my marketing people like this garbage bag image, I'm not saying those things are actually bad ideas, but here's what I am saying. Those things are not what machine learning is good at. That's a compensation in a tool or a technology or a platform. What I'm trying to tell you is that the data is really the problem. If we could figure out the data, then we can solve the issue. And maybe the problem was that at the level of the SIM, all the way at the top, we couldn't resolve that data, at least not in the form it was in right now, all right? Now, who could do that? Before I answer that question, I've got a question for everybody. Maybe you don't want to admit it, but who had the title of Webmaster at some point in their career, right? I don't, by the way, mean that kind of Webmaster. Let's just get rid of him. Did that hurt? Did that hurt? Oh, come on. But that's not the kind of Webmaster I mean, clearly, right? Here's the thing. Webmaster is a ridiculous title, right? But when we look back and we look to who now we are, or who other people are that were webmasters, these are highly paid professionals with skills in all sorts of areas that ended up someplace that wasn't well defined at the beginning. So they had a ridiculous title like webmaster. Maybe you've heard the title data scientists, right? My prediction, and I didn't need machine learning to make it, is that data scientist will be like webmaster at some point, right? Right now, people who are called data scientists are kind of maybe a little mocked here and there, right? But I'm telling you, these people are absolutely critical. Because think about everything we've set up to this point. What is it that you really need to do? You need to get into that data, you need to create workable features, and you need to create a model. That's going to require two things. We are identity and security experts. That expertise is required. But did you already solve the SIM problem since I showed that slide? Again, if you did, outside. But I'm guaranteeing most of you did not. I know I didn't, right? And the data scientist's skills are to take our expertise and focus them to figure out where to put those little whiskers on those little cars, to put them through a model that's actually constrained in a good way. That's why they're important. So, we call it data science because features are hard, right? And the thing is that this stuff needs to be very close to the data, right? And sometimes that third-party perspective the data scientist brings in is an analytical view that maybe we don't think about, right? Because we're too close to the data ourselves in a different way, right? We think of the data in a semiotic context. We give it meaning, right? But they don't care if it has meaning, right? They care if the whisker is the right length towards the wall so that you get meaningful results out of it. And, you know, algorithms get attention because they're cool and they're important. And that's another thing the data scientist brings to the table. Which algorithm matches your data, right? I don't know that answer. I bet those people can help you get that answer as well. Okay, so we follow the bouncing Deadpool, and this is the story of the journey from STEALTHbits, right? Essentially, we came out of the gate trying to attack this problem at that highest level, right? We figured we could take over the world and create a SIM product with machine learning. We built this huge architecture with Spark and all this fancy stuff, and it just crashed and burned. We took it into a couple of alpha sites, and I mean, it was just awful, terrible. We took it away, we licked our wounds, and then we tried to figure out what we did wrong. That's when I learned all the other stuff I've already talked about. So in case I seem wise and learned, I'm just beat up, you know, with a good cover-up over the bruises right now. And the idea is that we had to learn the hard way that you have to be close to the data. Now, lucky for us, and this is the only thing I'll say about my company and products, we know a whole bunch of data really well. We're really good at unstructured data and the way the credentials exist in enterprises. And so we were able to take that and make some really interesting things happen. And that's where the title of the talk comes from. We discovered that if we take the machine learning and put it all the way at the bottom of the stack, where we knew the data, we could make something useful, right? And so we have a product in the market, Stealth Defend. That's the biggest marketing you'll get out of me today. But that scaled back approach was successful. And I would suggest to you, vendor and organization alike in the audience, you should follow the same model, right? Scale back, figure out what you're really expert in from a data standpoint. That will be how you use machine learning effectively, okay? Now, to learn all this, I didn't do it in isolation. We didn't talk about like 90% of machine learning, but if you're curious like I am and you want more resources, I give you a couple here. At the very top in the upper left hand there is the 3 Blue, 1 Brown YouTube channel. They have an excellent series about the mathematics behind machine learning. So if that's what you're into, it's about 90 minutes of math on YouTube. Sounds like a Saturday night to me. Sadly, my wife can attest that that's true. So the master algorithm, if you're looking for an excellent way to get a full tour of what's the state of the art in machine learning today across a lot of different disciplines, I would definitely recommend Pedro's book for that. If you want to impress your boss with understanding the economics and how it's applied, then you'll want to read Prediction Machines. Ajay and his team laid out a really good case. By the way, they're economists. That work with VC firms and are exposed to technology through that. So they bring a really interesting perspective to the problem. And last but not least, in the small print down there, if you want to get your hands dirty, you can go to machinelearningmastery.com, where essentially they give you labs and they give you data to work with. So you don't even have to have your company release data to you to actually get hands-on and do things with machine learning. Okay? And that is all I've got for you today. So I'll be ready for questions when you are. Any questions? Yes, sir. Oh, hold on.
I saw a hand.
He raised his hand just as you walked away.
Can you define feature a little more, or
Sure.
just expound on that?
Sure. So a feature, essentially, is what you measure in the data to understand the ultimate result, right? So think of it this way. In the car video, right, the speed of the car going through the maze was clearly important to the car being able to make all the turns and get through. That would be a feature that you would measure to basically affect the ultimate result. I don't care necessarily what the size of the car was. The car could have been half that size. Well, probably couldn't have been twice that size, it wouldn't fit through. But you get the idea. The size of the car was not a feature, because it didn't matter. In data, you're going to have a huge amount of noise, right? Think about the sim example. There's going to be a huge amount of noise in there. What you need to do is find the 5 or 6 needles in that haystack that are important things that you would measure that would make the difference in the outcome that you want. Because remember, when we're talking about machine learning, we have the data, we know the outcome, right? It's how we get there. Features are what's important to the outcome in the data. There are things that you would operate on in the machine learning system itself to get a result. Okay? Vlad, you are not allowed to ask any questions. Okay. Okay. Just want to be clear. Yes.
I run a startup, and we use machine learning fairly extensively.
Okay.
And
I got all of this wrong. Is that what?
No,
Okay.
I'm not actually going to argue with you. A lot of these are fairly fundamental concepts for us, but we're using like k-means analysis, gradient descent, neural networks, all that stuff. One of the challenges that we're encountering, and I'm not sure if this is unique to our space and authentication and identity, is getting the learning data. So we're having to self-generate a lot of the learning data to teach our algorithms. And I'm wondering if you know of any sources or just... Please don't laugh.
Yeah, no. I'm laughing through. It's empathy. It's empathy. So I can give you 2 things to think about here, right? Number one, the way we did it is we worked with our customers, right? Now you said startup, so that might imply no customers, which would be inconvenient. The other thing I will tell you is. If you were to make your way down to the ID Pro booth and join ID Pro, and let's say you asked on that mailing list for anyone who had data they could release of that nature, you might find some very cooperative souls who could do that. And I think that would be fruitful. Let's put it that way.
One more, and then I'm going to release you all for lunch.
I have a whole 27 seconds. Okay.
Given there's been a lot of talk here about using AI and ML, obviously, for identity management, but given the amount of data that's being used for that, different identity factors, the different behavioral data, et cetera. Do you see that as being particularly problematic, like more so than SIM, applying machine learning for SIM for something that's been around for a long time, like a product like SIM?
Do I see it as being problematic? I don't think so, but I'm not sure how it would be problematic. I'm not sure what line you're thinking. But let's put it this way. I do think that a lot of what I'm hearing here at the conference in terms of applying machine learning to authentication problems in particular, it's extremely fruitful, right? You know, to the gentleman's point, these are basic concepts, and as long as they're getting these things right and they're designing the systems well, and like I said, go see Eve's talk if you want to see something that was designed in an excellent way applied to these problems, that there is good work being done here. That said, we're at a conference that generally attracts pretty cool individuals in that sense. So there's a big confirmation bias in Boston right now. Because there's definitely people doing bad stuff out there, but you're probably not going to find a lot of it here. Right? Oh, come on, one more. Because I saw a hand that was there. No? Well, it wasn't yours, but that's okay, fine. Go ahead.
So you didn't end up doing the SIEM. Did you apply machine learning to something else then that was successful?
Yes. So what we did, did my marketing department pay you? So we look at the thing we have on the market right now. It's not the only thing we're working on, but the thing we have on the market right now is a product called StealthDefend. We look at unstructured data, right? So files and folders. Super boring stuff by most people's estimations, but also incredibly toxic material in every organization. And we understand both how that's used and how that's secured, probably better than most of the companies on earth. So we went back to that, and that was the expertise we had, and we found it, where we found the SIM stuff really challenging, we actually found that working with the data scientists that we had and applying that expertise, it got easier. Not only was the work better, it got easier because we were able to use the expertise to create features that were meaningful because we knew the outcome we wanted. And we also, frankly, too, we kept our goals a little simpler. At the moment, really what we're looking for is outlier behavior and things that would be indications of things you might want to look at. Things that eventually, by the way, will feed up to a SIM, right? Which at some point might have a normalizing effect on data, which means at some point maybe you can measure things at the SIM layer, but that's another talk. Right. And I guess that's it.
Awesome. Thank you all for attending. Thank you, Jonathan. We've got